Atoms have a positively charged nucleus, composed of protons and neutrons, and a negative electron cloud consisting of different energy levels. When the cathode and anode of a cathode ray tube are connected to a voltage source, electric current flows through the tube and can be seen as a cathode ray. The cathode ray is made up of electrons. When a positive electric field is placed next to the tube, the path of the electrons moves toward the field. Using the strength of the electric field and the amount of deflection, J.J. Thomson was able to calculate the ratio of the charge of electrons to the mass of electrons. Imagine a baseball player throwing a ball. Like the cathode ray, with no outside influences, the ball goes straight when the baseball player throws it. A strong wind, however, could blow the ball and make it go off course. An outside positive field attracts the electrons in the cathode tube and makes them go off course. If the baseball player threw a lightweight plastic ball instead of a regular baseball, the wind's effect would be even more evident. The mass of the ball is one of the factors that determines the path the ball will take. Similarly, if the wind were stronger and the baseball player used the original ball, the wind's effect would be more evident. The strength of the outside force is one of the factors that determines the path the ball will take. By observing the path of electrons in the cathode tube, Thomson was able to calculate the ratio of charge to mass of an electron. In Millikan's oil drop experiment, he squirted negatively charged microscopic droplets of oil into a chamber and observed them with a microscope. Voltage applied to metallic plates within the chamber allowed him to create an electric field, which had an effect on the droplets. By adjusting the electric field's strength and direction so that it pushed the droplets against gravity, he could suspend the droplets. By knowing a droplet's mass and the strength of the electric field needed to suspend it, he calculated its charge. Testing several droplets in this way, he found each droplet's charge to be a whole number multiple of 1.602 times 10 to the negative 19 coulombs. This is the charge of an electron. Ernest Rutherford, with Hans Geiger and Ernest Marsden, discovered the nucleus of the atom using a beam of positively charged alpha particles. They bombarded a sheet of gold foil with a stream of alpha particles. Most of the particles passed straight through the foil. About 1 in 8,000 particles, however, were deflected, sometimes directly back at the source. Rutherford explained these results by hypothesizing that nearly all of the mass of an atom is concentrated in a very small volume called the nucleus. If the nucleus were small, it would be easy to miss. Alpha particles which miss the nucleus are deflected only slightly, if at all. Alpha particles which hit the nucleus are deflected severely.